Good morning dear students. In the today's class, I am going to continue the next session, that is we are going to derive the refractive index using prism. Okay, we are going to derive the equation or we are going to obtain the refractive index of the prism. Okay, so here also optical medium, prism acts as optical medium. Similarly, the phenomenon's refraction takes place. Okay, so how we can define the prism? Actually, prism is a two triangular, okay, it will be consisting of two triangular surface and three rectangular surfaces, in which two rectangular surface should be non-parallel and it should satisfy the refraction. Okay, two triangular face and three rectangular faces. In that, two rectangular faces will be refracting faces and one will be opaque. Okay, so if it is a prism, A, B, C is one portion, P, Q, R is the another portion. Here A, B, C is one triangle and P, Q, R is one more triangle. Three rectangular faces, that is A, P, Q, B is one face and one more face, rectangular faces which is non-parallel to each other, A, P, R, C. One acts as the base of the prism, that is B, Q, R, C. Okay. So here this portion and this portion acts as a refracting surface. Here base which will be acted as a opaque. Okay. And you can see the angle between two refracting faces. The angle between the two refracting faces gives you the angle of prism. What is that? It's the angle between two refracting surfaces. So here these two refracting surfaces should be non-parallel. That thing you should remember. Okay. Alternate the angles, alternate these angles where two refracting surfaces that creates an angle that is called as angle of the prism, or simply it is also called as refracting angle. Angle of the prism or refracting angle. Okay. Next, I will consider the principal section of the prism. Principal section of the prism. Okay. A, B, C. BC is our base. Here this is angle of the prism. Let A be the angle of the prism. Okay. Next, I will consider one incident ray which get incident on the first surface. Here QR is the refracted ray. Okay. Next, for the second surface AC, okay, for the second surface AC, QR is the incident ray. When a ray of light is traveling from denser to rarer medium, if I draw the normal to this point, what happens? When a ray of light is traveling from rarer to denser medium, after phenomenon, the emergent ray bends away from the normal. The emergent ray bends away from the normal. Okay. If I remove this prism, if there was not any prism, prism was not there, then the PQ would have traveled a straight line path. Instead of undergoing the deviation or the refraction phenomenon, undergoing the refraction phenomenon, the ray would follow straight line path. Okay. So here RS is the emergent ray. RS is the emergent ray. If I draw the emergent ray line in the backward direction, I will get one angle. That angle is called as deviation. Deviation of the prism. Okay. Now we can define the deviation. It's the angle between the incident ray and the emergent ray when it has been drawn in the backward direction. So this will be straight line path. Here, if I make this mark, this portion as Z. Here, Z T is the deviation angle. Z T is S is the deviation angle. Okay. Let this point be where these two normal they join, let that point be N. Okay. So for the first surface, I1 is the incident ray and R1 is the 180 degree. Sum of all the three angles will be equal to what? 180 degree. That is R Q N. Okay, angle R Q N plus Q N R plus N R Q will be equal to what? 180 degree. Here the value of R Q N is R1 and Q R N is R2. Okay. In triangle Q N R Q N plus Q R N plus Q N R equal to what? 180 degree. Substitute the value of angle R Q N and Q R N. What I will get? R Q N means R1 plus R2 plus Q N R equal to how much? 180 degree. That is value of Q AR. This angle value is simply A. Okay. Next, if we compare equation 1 and 2. Okay. Next, compare equation 1 and 2. So see here, QNR and 180 degree remaining, we can equate A is equal to what? R1 plus R2. Okay. From equation 1 and 2. From equation 1 and 2, what I get? Angle of the prism A is equal to R1 plus R2. Consider it as a equation 3. Okay. Next, here we know that for an exterior angle, sum of the exterior angle will be equal to the sum of the interior opposite angle for a triangle. Here Z Q R is one triangle. Okay. In that case, exterior angle is what? T Z R or T Z S. So exterior angle of a triangle is equal to sum of interior opposite angle. Exterior angle of a triangle is equal to what? Sum of the interior opposite angle. Okay. Exterior angle means Z T S. Z T S will be equal to Z Q R plus Z R Q. Okay. Actually, this value is deviation D. ZQR is I1 minus R1 plus it will be I2 minus R2. So I will show you this value. So I will take this line. Actually, remaining Z, Q, R is nothing but what? I1 minus R1. This value I1, small value R1. So this portion, that is Z, Q, R is what? I1 minus R1. Similarly for this case also, ZR Q will be equal to what? I2 minus R2. Okay. I2 minus R2. Rearrange the term. D is equal to what? I1 plus I2 minus R1 plus R2. From equation 3. Okay, from equation 3. What's the value of R2 plus R2? Which is nothing but angle of the prism. D is equal to I1 plus I2 minus A. It's the deviation value of the prism. So, for problem part you should remember this equation. D is equal to, it's the deviation, I1 plus I2 minus A. From this equation what we can say, for a deviation there will be two angle of incidence. For the same value of two angle of incidence, we will be having same deviation value. In order to understand that concept, I will draw a graph, and then x-axis represents the angle of incidence and y-axis represents the angle of deviation. Okay. So x-axis represents angle of incidence and y-axis represents the deviation value. That's the angle of deviation. Okay. So for this small angle of the prism, it has been found that deviation will be less as the angle of incidence increases. As the angle of incidence increases, deviation value decreases. Okay. Next, at certain phenomenon, the deviation will be minimum, and once again further increase in the incident value, deviation value once again increases. Just carefully observe the graph. Initially incident value was less. What happened? Deviation value was more. As we go on increasing the angle of incidence, what happened here? Deviation value has been decreased. Okay. Once it reaches the minimum value, for this value the incident value will be single, same, one angle of incidence value. After that value, once again the deviation angle value what happens? Increases. Okay. So this point where the deviation is least, that is called as minimum deviation. So minimum deviation is obtained when angle of incidence is symmetric. Minimum deviation is obtained when angle of incidence will be symmetric to the base. Okay, but this angle will be, this ray will be parallel to the base of the prism. Okay, so if I apply the deviation value, see here, if I draw this value straight line here, for the single deviation I is 2, I1, I2. See here, for deviation value, angle of incidence will be 2. That means I can retrace the path. If it is the angle of incidence, for the same value I will follow, retrace the same path in the opposite direction. If D is the minimum deviation value, in that case angle of incidence, that is I1 will be equal to I2 will be equal to I, and R1 will be equal to R2 will be equal to what? R. R1 will be equal to R2 will be equal to R. Okay, substitute here. Instead of writing small d, replace it by capital D. terms of I will be equal to what? A plus d by 2. I is equal to a plus d by 2. And equation 3 can be written as r is equal to a by 2. Equation 3 can be written as r1 plus r2, r plus r, 2r, or r is equal to a by 2. How can I write? R is equal to a by 2. Next, I have to write the refractive index. Generally, I know that refractive index of the prism with respect to a n is equal to sin I by sin r. Then directly substitute n is equal to sin a plus d by 2 divided by sin a by 2. It's a 5 marks important derivation, or may ask 5 marks problem. So it's the final expression. Refractive index of the prism is what? N is equal to sin of a plus d by 2 divided by sin a by 2. Okay. So what do you mean by minimum deviation? So in the minimum deviation, angle of incidence will be equal to angle of emergence. Okay. So in the next session, I will continue regarding the angular displacement.